Yes, we were talking about actually the merge statement and how actually we'll be able to even encapsulate the merge more than its capability. So the merge, we've seen it as a solution to merge different functions to facilitate actually the interaction and the interrogation of database. We are able to merge two entities with the consideration of um, available methods in the sense of if we're going to update a table, it depends on a second table, so we have to consider the matching or the non-matching values. Then after we are going to update and we retrieve and we insert, we are going to do whatever we want. Thus, the merge statement can help us in do that in just one shot, in just one call. It is not to be interfered, not to be interrupted. It is not to it is to guarantee that the query would be actually terminated up to the end without interruption. The request, not the query, and the request might have more than one query. We might have actually a select, an insert, an update, all together to be executed. So they are three different queries that the merge statement would ensure and assure both that those three queries would be executed altogether or failed altogether. So this is the one of the capabilities of this merge statement. Yet it's not only, we do not stop at this level only. I'll come back to this methods table. It's not only the T-SQL does not actually stop at this level. It gives us another chance to encapsulate it more. In the sense of we can insert a merge statement from within a procedure or stored procedure body. We'll be able to call the merge statement whenever needed based on the use of the variables or variants we require. So we call the merge. The stored procedure it provides us another perspective, which is to reuse it again and again and again whenever we need it from within the life cycle of the project, even after, and here not even, but here we talk about at runtime only. I come back to the methods that we may actually, we discussed this, but it's a small recap. The methods that we may think of whenever we build actually a merge statement. The merge statement would merge two entities. We will have actually a target and a source. Those two entities that would be actually merged, they are based on a function that we have to think of. It's not a function, it's a method. If there were a validity, similarity, a matching value between the first entity and the second entity, or there is a non-matching value, yes, we can go for a matched or non-matched value. So between the two entities, in both scenarios, we may think of it depends on the request. If there is no match, so we have to update. If there is a match, we have to update. It depends on the request only. What is the business we are doing? The example we took last class, it was about to update stock based on a sale process. So in this regard, if there is any sale, new sale, so we have to update either to add or to decrement. Good. Any questions here, please?
No.
That is great. That is great. Okay, since yeah, okay, great, great. So later on, actually, just one other hint is that the stored procedure created, which holds a merge in its body, later on how to call this merge statement. We have to execute only the stored procedure. In our case here, in this example here, the stored procedure is nominate user stored procedure update books, USP update books. It's user defined name, this word here. Later on, we just call that name, or we may call this name preceded by the word, the keyword, exec. That's it. The merge statement would be executed at the end. Okay. Regarding the group context, it's another scenario here which we may see an enhancement given to the SQL list of queries is that to retrieve data but based on groups. More or less, so group by, it's like the order by, but we are going to just display a group of values grouped by a value, an item, a field, something like that. The example we are taking here is to group an outcome based on the item or the color. We are going to specify we are specifying the fields to display from the entity. Simply group by what the field given here is item. So the item would have actually a duplicated list of values. Those duplicated list of values would be used to display the other properties, the other attributes. So this one would be actually, then after also second group inside, after grouping by the first criteria, we group again by color. It's like that. So it's a sort of redisplaying, restructuring the display. One of the positive facts of functions that we can actually utilize and have the benefit of from within an SQL query is the use of the aggregates. The use of the aggregates. What are the aggregates? Mathematical functions that would actually be given us a functionality, searching for, let's say, a sum, a total, a mean, a max. We may do a calculation even from within a query body itself. We can do that, absolutely. All of those methodologies that actually would help us, they are called aggregates. Example of aggregates, we are going to count, for example, the number of records. We are going to count the number of records in a given table. We use the word count. It's not a word here, it's a method. This is an aggregate since it is passing within the body of the query. We are going to write select count star. We are going to count everything star. Or we may say select count ID. How many IDs are available? Select count product. How many products? How many products are available? And so on. From a list of GPAs. Which GPA is the highest? Whose student is having the highest GPA? We use the max method or max aggregate. Select max GPA and so on. So there are a list of aggregates that we may integrate from within the SQL query itself. And those aggregates, they are actually upon to the need. Does not mean that we have to use them, but available for us to use them whenever we need, no more, no less. As per the example you see here, see the outcome here, see the outcome here. We are having a column, the field named rsum. Here is the rsum. A field rmax. Here is rmax. Rmean. Here is rmean. But the entity inside, in this example, it's TXN data from TXN data. It does not have any field named rsum, rmax. Come back to the book and you'll find that. It is, those are headers. Those are headers, literals. They are literals. A header to which you are going to put the sum. A header to which you are going to put the max. A header to which you are going to put the mean, and so on. Any questions? Any questions, please?
No, doctor, thank you.
No, mister.
Great. And great.
مستر السؤال ما واضح، أنا جاي أحله وسكر.
وش سؤال؟
واللي بو كلاس روم.
No, قفلته 9 دقائق أعتقد. Um, regardless, it's not a big issue. We rectify that inshallah. Okay, we continue in the context of the aggregates only. Still, analytical functions, they are also defined with the T-SQL only. Analytical functions, they are also defined with the T-SQL only. Those analytical functions, they are also to facilitate the life of the developers and to give us the chance to secure our process in terms of information assurance. And in addition to that, they would actually give us a more accurate values depending on whatever we need. Examples, they are listed here, and you can refer to your book, chapter 2, and we are going to define some of them, not all, because it is a long time. You just refer to the syntax how they are, but even though they are having so much similarities, uh, in a list of values, we may check actually the first available first value. This is an analytical function that might it's a method. It returns actually the first value. This is a function. The last value, it returns the last value in a list, last value in a field, last value in a list of output data. Lag and lead. Those are very perfect two analytical methods since they are actually capable to work with the context of the prediction. They might help us to predict future values. The lag, it reads what happened in the history of a given, let's say, field, and the lead reads what it might happen and then actually what happened and what it might happen in the next generation of a given field. Lag, early, sorry, what happens earlier. The lead, would happen next. Lead, lag is lag, literally said. They are two English words, lag and lead. They are methods here in our context in the T-SQL field, T-SQL enhancement. They are methods. We will see examples based on that. The others will come back actually. We'll come back to the others. Okay, syntax. Syntax. Of the lead and the lag. Just let me. So I believe you're able to see the screen. Are you able to see the screen, please?
Yes, Mister.
Okay, great. So in this graph here, actually, let me open it. Another window. In this graph here, we are able to see an entity here in this window here. We are having a normal and a regular field from a table. This is a field, join and date. Yet we are adding another field in which we are reading the lag value. The lag value is seen here starting from the second record. It's not the first record. The second one is displaying the first value from the join and date. The third record is showing the second value from the join and date. The fourth in the end date, the fourth record is shown the third value from the join in date, and so on, and so on. So what we understand here is that the lag value is the returned value from the previous happening value. We have actually the join and date, this field here, is the regular field with its values from the entity. The end date. I come back to this window. Let me show it to you. end date. Here it is. You see this window here? You see what I'm highlighting? It's a literal given
Yes.
to a, yes, good. So it's a literal given, it's a header given to a field in which we are extracting a value from a field, from a field. Step is one. So we are just reading the joining date. This is the entity, this is the field. We are reading the value from here, and we are giving it a header, no more, no less. But step one, we are reading one step before, one offset. So as per the syntax. So let me just show you the syntax. Yeah, the syntax of the lag. It is to have the field name. The offset means the step to do, and then after, if you want to have actually any other parameters like the literal, the header, we said here the header. Yes, the header, literal. So we are given one step back because of the lag. If you are talking about the lead, if you are talking about the lead, are you able to see the window?
Yes.
Yes, great. So here the lead is the same context, yet we are going to do an offset further forward. It's the next step, or the next two steps, or the next three steps is the same syntax. It does not differ at all. Yet we are going to read the future values in the lead, and in the lag we are going to read the previous values, no more, no less. So two analytical methods that they would actually enhance our readings, regressions, using a default and the preset methods. Those are actually two T-SQL enhancement. I'll ask you later on as an activity to do for the definition of the syntax of those, let's say, chronological sequence-based methods. Good. And other aggregates, which are purely mathematical functions. We can see the log actually, which is a logarithm. I think it's a pure mathematical function that gives us the surface or superficie or spatial calculations. Well, once needed, it can be utilized. One consideration here is that it's not that we can use the log only, but due to the definition of the logarithm, this mathematical method, there are versions, there are distributions of this log function. Previously, it was used since the early age of the SQL syntax. It was used, and since the early age of the definition of this log, when the SQL has been came to life, it was used. Yet there are distributions, and because of that, we have to specify specifically each log to be utilized and when. When referring to the T-SQL enhancement, this consideration has been took into consideration, yes, and there have been defined one new method named log also still, and it is two parameterized to specify which distribution to utilize with its value to apply distribution and the value. So for this example, the first one we see in here, we are going to calculate the log of 12, 11. It is a number, whatever. We haven't actually a process to do. But based on which version, based on which distribution? The log base 2. This is a math function. So we are calling two methods here, and here, and we have to respect the syntax. See, we are making as if we are dividing. Otherwise, it will not work. Using the T-SQL, completely different. No, we just call one log. We give it two parameters. It works. The first parameter is the value. The second is the distribution. So this is an enhancement. This is second. This is another enhancement of the actually the log function from within the SQL bodies. So here we do not stop at this level. We do not stop at this level. It is actually as you can as per our book, it is 4 pages you have to read fully. So it is a little bit long. I'm just making a summary. I'm just retrieving the most important parts from those aggregates. Any questions before I continue, please?
No.
Yeah, great. So great. So we keep going on. So the throw is one of the features that the TSQL, it's not the SQL, the TSQL is enhancing to us. Runtime errors is one of the considerations that we have to tackle. What does it mean? It means that we are building a solution, we are actually implementing a solution, we are developing a solution. Syntactically, everything is correct. The debugger will not find any error. The API, once we debug the solution, will give us actually 100% successful build, means everything is fine. Yet, once we deploy to the online project, once we deploy our solution, our database, and our project fully to the online, values would cause issues. Those issues, they are said runtime errors. They are exceptions. We talk about exceptions. So the runtime errors, they are exceptions. Exception cases, or exceptions, define exception cases. They do not appear when debugging. They do not appear when developing. At that time, we have to, developers actually have to consider all the possible runtime errors to control them, because they do not have to change the program run, but they have to control the inputs. They have to control the flow of the data. See what I'm saying? The inputs or the flow of the data in order to control the runtime errors. And those exceptions or those runtime errors is the same meaning. they have to be actually controlled. And this control here, it is to be done based on a predefined methods. We talk about the throw method. It's one of the statements that can help us to control the runtime errors. It's a security measure to make the work within a project run smoothly. As per the example we see here in front of us, it's a math to be happening. If I ask you here where I'm pointing now, see, we are declaring a variable, a user-defined variable number. See the at, we defined this earlier. We know this syntax. It is to hold an int, and we are initializing already. And the initialization here is done. See if you can see the number. Are you able to see where I'm pointing, please? Is it visible to you? Great, great. So if we subdivide this 5 by 0, what is the error? What is the issue? Is there any error here? Can you just define any error here at this position? Mariam, are you able to see any error in this statement here, in this line here? Are you with me? Let me ask you by question, by name. Jahin. Not Juhaina, I need Juhaina. The question is to you, Juhaina. Are you able to identify any issue in this line here, in this statement here? Are you able to identify any issue?
I think number.
What is the number? What is the problem? What is the issue? We will talk about runtime error, an exception. There is no error actually. Syntax, it will not be an error. Absolutely no. So if we compile, it will give us a perfect correct program. But once we run it, it will tell us this is an error. What is it? We cannot divide by 0. We cannot divide anything by 0 because it is an infinite mathematical rule. Anything divided by 0 gives infinite. We cannot have any number with a size infinite. It's not measurable. This is an exception. Thus, there have to be a control of this exception. If this execution happens, there is a block to be launched instead. This is not an error. This is actually a runtime error. It has to be controlled. And this block here, we have 2 blocks. We have 2 blocks. See here, begin try and try. Then begin catch, then and catch. The first block begin and, we have all what it has to be done. I repeat, here in this first block, we have all what has to be done. If something happens in runtime, if any error happens here, the second block would be executed. The second block will not be executed at all unless there were an issue happening at the first block during the runtime. Otherwise, no. So clear here. We have 2 blocks. The first one would be executed for sure when running. But if any issue happens during the runtime here, there is a constraint, the second block would be executed, will be launched. We have the beginning, we have the end. This is a T-SQL structure. This is a runtime error control. We are using a throw to not consider the error and continue the work. To eliminate what errors raised here, to eliminate them and continue the program. Draw. Using this method here. Any questions, please? I insist on this block.
Mr. Again, this. please.
Yeah. Yeah, sure. The exceptions or the one-time error, they are errors happen due to the inputs or to the list of values of the data flow during the running time. Once the program is already deployed and online, whether it is a database only with its interface, or it is a full project running and using a background database. What does it mean? Means once the developer is developing this program, nothing would be seen here. Nothing, no errors would be actually detected when developing. Syntax is completely correct for all. Full block is correct. Syntactically is correct. So what's the problem? The problem is that later on, if the user inputs values, or there are calculations to happen and causes new values to appear, or there are submissions, something to happen during the run of the project, there are flaws to cause new values to appear. Those values might cause issues. We'll define this issue here. And those issues, they appear only during the runtime. So the program is correct. It does not have any problem. But though there are cases like the example we see here, the division by zero, cause the full program to stuck. Can you represent the infinite? Nothing, because any object, not any number, any object divided by zero gives an infinite. It does not have the chance to have a result here. Nothing to be represented. This is a complete exception. This is a complete, actually, bug. It's a complete bug to the computer. The processor cannot resolve that. Thus, it has to be actually controlled by the developer. And this view here, we are seeing two blocks. We are seeing two blocks. The first block, it holds this statement, which is syntactically correct. It does not have any problem. And we are having a second block that actually would be executed only if the first block, which is a try block, only if this block holds any problem during the runtime. Otherwise, this block will not be run, will not be run. This is to catch the errors and to draw them, to catch and to draw. So let's see the content of this statement. We are having an initialization of a variable, user-defined variable, already declared, with 5 divided by 0. This initialization, it will not be happening. Why? Because we cannot divide the value. He cannot have any representation. The processor will stuck actually. It is a bug. It is a computer bug. Good. So this bug, how to solve it? By running the second block, which is the begin catch, until the end catch. So this second block would be launched due to the division by 0 here in the first block. And this second block will say to the computer, to the program, or to whatever, hey, draw this issue here and continue. Don't stop. Don't cause the program to crash. No, continue. Draw it. Draw the problem and continue. It is like that. Can you repeat what I said right now? Okay, I hope it's very clear. I hope it's very clear. Let's continue. Server-side page, and actually it's another context that the T-SQL has enhanced. It is server-side in the sense of we can actually call such group of methods for ranking or for, let's say, paging, but from within the SQL Server itself. The server we are talking about is the SQL Server. So from within the SQL Server itself, we may call ranking and paging methods for different, let's say, sorting, or let's say ordering the list of queries or whatever we are having. They have to be actually displayed at the end, the front end. Yes, but they would be actually launched from the server side, no more, no less. Regardless. paging. Nothing is crucial here. Nothing is hidden here. Actually, we are just declaring variable and we are making an output, and the output is from select from what from another interrogated entity, a person. We are going to interrogate specific output, and this output would be actually interrogated again to be displayed. We interrogate and we interrogate. It's a compound query. I'll receive your requests later on when you open your book and you refer to this statement here, the context of the paging, because this is a very simple statement. If you understood the merge, you'll be able to understand this context of paging here, this compound statement here, this compound query, sorry, here. Okay, by this actually we reach an end of this chapter, this unit. If you have any questions, please raise them up. Otherwise, if you hear your name, just say, yes, I'm here. I'm going to stop the recording.